Okay, good afternoon, the grade 12s. This is Mr. Ndabezita, and this time we are looking at pure mathematics for grade 12. And never mind Thomas Calculus, for now we are in grade 12. So, this is a question paper, the National Senior Certificate Basic Education in the Republic of South Africa. And this is grade 12, mathematics paper 1, November the previous year. So we just want to check exactly what was happening here, how the question was structured, and then how things should be done. Unfortunately, I don't have a memo for this, but I think I know what is to transpire. So let's just get right into it. So first of all, we come across the instructions and information. Very important that before you can attempt to solve any problems, you need to pay attention to the instructions and the information that is provided. So they say read the following instructions carefully before answering the questions. Okay, that is fine. The first point, this question paper consists of 10 questions. Answer all the questions. You may leave some, nobody will do a thing to you. Number the answers correctly according to the numbering system used in this question paper. Very important that you do that. Clearly show all the calculations, the diagrams, the graphs, and so on that you have used in determining your answers. We will follow very, very closely with that. Answers only will not necessarily be awarded full marks. So if you just provide answers only, unfortunately there will be some consequences because the steps goes along and there are some of the marks that are provided on the steps that are required. So it is very important that you not only show all your final answers but also the steps that are necessary for that. You may use an approved scientific calculator, non-programmable and non-graphical unless stated otherwise. That one you can skip. Honestly, we completed our metric using programmable calculators. We were able to do stats with these calculators. We were able to factorize with these. So they were exactly programmable and nothing was ever said about that one. Okay, let's go to number 7, but please follow that instruction. I'm very sorry, please follow that instruction, non-programmable. But even if you go with a graphical calculator and a programmable one inside, nobody will do a thing. If necessary, round off answers to 2 decimal places unless stated otherwise. Very important that you follow that one. Number 8, diagrams are not necessarily drawn to scale. Okay, that is fine. An information sheet with formulae is included at the end of the question paper. You will surely need those formula sheets. And then the last one, you should write neatly and legibly so that whoever is marking your script can be able to follow what you have written. So you need to be of a sober mind when you deal with this. All right, in question 1.1, we are confronted with this solve for x problem, and we have 3x minus 6 in bracket and x plus 2 equals to 0. So you have a product that is equals to 0, and we use the product rule. Whenever you have two products, multiplication, and they are both equals to 0, you take the first bracket, which is 3x minus 6, and you equate that to 0. And also you take x plus 2, you equate to 0. The first bracket, but you don't include those brackets. You just say 3x minus 6, that is that which is inside of the bracket is equals to 0, or that which is inside of the second bracket is equals to 0. So remember, we are solving for x. Any constant that doesn't have x, let it go to the other side of the equal sign. If it was positive, it becomes negative, and if it was negative, it becomes positive. So this side I have 3x, I've taken minus 6 to the other side, and it becomes positive. And when I continue with that, I will find that 3x is equal to 6, and remember I'm not looking for 3x but for x. Therefore we divide both sides by 3 because I want to find x. You divide both sides by the coefficient of x, which is a 3, but what you do on the left you also do on the right. So 3 into 3 will go once, you will be left with your x. There it is. How many 3's can we pull out of 6? 2 of them. So we are done with that one. And then we can come here, x plus 2 equals to 0. Take this one to the other side because it doesn't have x. It is positive, therefore it will become negative. So you have just basically solved for x. X is 2, or x is equals to minus 2. So that is fine. I believe and hope that you have understood that problem. Now, this is the structure of question 1. The entire question 1 is worth 25 marks, and we solved 1.1.1, and now we will go to 1.1.2 until we are done with 1.4. So let us continue in here. So we have 1.1.2 and we have 2x squared minus 6x plus 1 equals to 0. Let's just double check. Sorry. And here we are, 2x squared minus 6x plus 1 equals to 0. In most cases, when they say correct to 2 decimal places, then one knows that a quadratic formula has to be employed. Right. And I couldn't even check whether it can be factorized or not. I just went straight to using a quadratic formula. Remember, it says minus b. Please, this is not a 6, it's minus b, plus or minus the square root of b squared minus 4ac divided by 2a. This is the quadratic formula. And remember, the coefficient of x squared is a, the coefficient of x is b, and our constant is c. So wherever you see that in your formula here, you just plug that, and then you will find, okay, sorry, here I've made a mistake. I used a positive. I don't know how I did that, because negative 4 times 2, it's negative 8. So it gave me those answers, and then when I double checked, I found out that they were wrong. So I used my negative there. So you will have negative 6 squared, which is positive 36. And then you have negative 4 times 2 times 1, which is negative 8. 2 times 2, it's 4. So basically what you have here, you have minus from the formula, there it is, but what is the value of b? Minus 6. Hence I have included that inside of the bracket so that you don't make that mistake. And then negative, let me just show you, negative by negative is a positive, and then you have that. And then what is 36 minus 8? Unfortunately, I didn't go through that algebra, it was unnecessary. I just plugged this. I just plugged the entire thing on the calculator and I got 2.88 using a positive. And then I used a negative. I believe and hope you understand this. And then I got 0.177. Remember, they said 2 decimal places. So you can just say 0.18 here. I'm sorry that I did not follow the instructions. Okay, that was 1.1.2. We can now move to 1.1.3, and there are 2 parts to this, but we will start here. So this is an inequality that we are having. So the difference between an inequality and an equation gives you a finite or a finite number of solutions, whereas an inequality will give you an infinite or infinite number of solutions. So that is just basically the difference between the equation and the inequality. So in university, when I was doing electrical engineering, we were taught this way of solving things. We dealt with differential calculus, and when it comes to inequalities, this is the best approach. But I'll show you, I'll take you through this. So we have x squared minus 90 is greater than x. So one thing that I want to do, I want to bring all the terms to one side so that I'm left with 0. So what I did here, I have my x squared minus 90. This is positive. When it goes to the other side, it becomes negative. And because you have taken this to the other side, when there's nothing left on this right side, we say you have a 0. Very important. And then I just rewrote this in a standard form of a quadratic, ax squared plus bx plus c. And there it is. And when you do that, please do not change and confuse the signs. Let everything be in the order in which it should. And then from there, when we are done, we know that we need to factorize. You ask yourself, can this be factorized? Of course. Can you find the factors of 90 that can give you 1? Yes. Right, let me show you how I did this, because it is very, very important that I explain that to you. Now, here we are, and let me just do this. The factors of 90, you just come here and you just say 90. This is a programmable calculator. It is acceptable in the exam. Let me be very, very clear with this. 90, then you say equals, and then you say shift, and then you press fact. You see? So you have 2 times 3 squared times 5, which you can say it's 2 times 5, which is 10, 10 times 9. There it is, 10 and 9. So that's how I got into that. Okay, let's just continue with this. Right, and then I have 10 and 9. It doesn't really matter where you put your 10 and your 9. It will not make any difference. But what is important is that the bigger number, which is 10, must take the sign of the middle term, which is negative. Now remember, when you multiply the two factors that you have found, 10 and 9, they should give you a negative. So if this is negative, this one has to be positive, because negative by positive, it's negative. And we can investigate this. What is negative 10 times 9? It's negative 90. So you are correct in this. And minus 10 plus 9 is minus 1. There's a 1 there. Alright, and then you calculate what we call the critical values, and then you just say this. Remember, it's a product that is equals to 0. So you just say x minus 10 equals 0 or x plus 9 equals 0. We dealt with this in 1.1.1. And you will find that your x is 10 and your x is minus 9. Nothing mysterious about that. Then we can continue further. Once you have found your critical values, you draw up a number line. And in this number line, you place your negative value and your positive value, because remember, on the number line on the x-axis, you have a negative first and a positive after. You are moving from left to the right, from the smaller number to the bigger number. And then from there, you say to yourself, you just say to yourself, remember, this is continuing in that direction and this is continuing in that direction. So you are actually moving from negative infinity to minus 9. And in here you have minus 9 and 10. And then you are moving from 10 to positive infinity. Here they are. And then you draw up a table of values. And what do? You take these 1, 2, and 3, and then you place them here. And then once you have done that, you take your equations. The first one is x minus 10, the factorization brackets. You have x minus 10, you place it here. X plus 9, you place it there. And then remember the product of those two. Hence I have this multiply. It's just the product of those two. You place it there. So you can just write basically here this entire thing. Open bracket x minus 10, close open x plus 9. You place it here, or you can just say multiply. There's really no marks for doing that. The table is not even marked. So it is just there for the sake of convenience and understanding. So we continue. Once you have done that, then you say what is a value. You just take a value that is smaller than minus 9. Just take a value to the left of minus 9. I know that minus 10 is less than minus 9, so just take a value minus 10. You can take minus 20, that's your choice. And then a value in between minus 9 and 10. You can even take 0. You can take minus 8. You can take 9. Anything that is in between minus 9 and 10. And then a value that is greater than 10, you can just take 11 to the right of 10. A value that is bigger than 10, it's 11. And then once you have done that, you just you just come here on this, and then you substitute minus 10. You say minus 10 minus 10 is minus 20, that is negative. You just write the sign, and then you come here, you say minus 10 plus 9, it will give you a negative, and negative times negative is a positive. And then you come here with 0. 0 minus 10, it's minus, and 0 plus 9 is positive. Negative times positive, it's negative. And then you take 11. 11 minus 10, positive. 11 plus 9, positive. Positive by positive is a positive. Now, this is your solution now. Remember what the inequality said. Where the value of x is bigger than 0, meaning where it is positive. Where did you find the positive? When you multiplied the product here and there. So your solution is this. But remember that minus 9 is included here. Please remember that minus 9 is included. So you will use that type of a bracket. Not the closing one, but the one with a box. Jesus, the boxed one. Boxing and unboxing in software engineering. I do a lot of stuff, please forgive me. So you will use that type of a bracket. But because we don't know where negative infinity will end, we will have this closing bracket. But because minus 9 is included, then you will make that type of a bracket. Even here, 10 is inclusive. You will make that type of a bracket there and closing one. And then you will make an open closing bracket there, just to show that we don't know where positive infinity will end. Very important stuff. Now we go for 1.1.4. And we are dealing with the square roots now. X minus 7, the square root of x is equals to 12. Remember, we are solving for x, so I will take this to the other side. Sorry, this is equals to minus 12. This is minus 12. Let me show you that. Here it is. It is minus 12. So please be very, very careful. This is minus 12. So x minus 7, the square root of x equals minus 12. I'll take this to this side, and it will become positive. It is already in a standard form. So the very first thing that I think it's important that I can do is to just simply remove the square root here. When I remove the square root, you leave what is inside of the square root, and when you remove the square root, you take the exponent of 1/2. This is very important. This is standard 5 and standard 6 mathematics. Good. And then once we did that, now we are dealing with something. Now this is x to the exponent of 1/2, and you have a 1 there, and I want to create identical exponents of x. So I know 1 is the same as 1/2 plus 1/2, and when I multiply, I add, and 1/2 and 1/2 will give you a whole. Minus 7x and 1/2 plus 12 equals to 0. So when I'm here, I can use the k method. Let x to the exponent of 1/2 be equals to k. So this is just to say where I see x to the exponent of 1/2, I am going to write k. Okay, that is fine. Let's continue. And here we are. I see x to the exponent of 1/2, two of them, so I will replace with k minus 7k plus 12 is equals to 0. So remember, where I see this, I just write a k, and there it is. And I know that k times k is k squared. When you multiply, you add the exponents, you will get there the factors of 12. That can give you 7. Somebody can choose 6 and 1. 6 and 2. But with 6 and 2, you're going to have a problem because you cannot get 7. So only 4 and 3 qualifies. So you will take the factors of 12, which can give you 7. It's 4 and 3. The bigger number takes the sign of the middle term. When you multiply them, you should get a positive. So when this is negative, that also has to be negative, so that negative by negative is a positive. And then we know what has to transpire here. We have at the 0 product, so you will say k minus 4 equals 0, or k minus 3 equals to 0, and k equals 4 or 3. But remember, what is k? It's x to the exponent of 1/2 equals 4, and this is equals to 3. And then you want to get rid of this 1/2. Then you will multiply both the exponents by 2, so that 2 into 2 goes once. You have a 1 there, you will multiply that by 2. So 2 into 2 goes once. You are left with x to the exponent of 1 equals, what is 4 squared? 16. The same is happening here. What is 3 squared? Is 9. And then you just having those values. Let us try to check whether both values are valid or not. Very important that we do that. So let me just quickly come here. And what I want to do there, I'm going to substitute here. So I'm going to take the first value of x, I'm going to substitute with 16 here. So I'm going to say 16 minus 7, the square root of 16, and plus 12. And this gives me 0. So the first one is valid. Let me check with the second one. So I will use a 9, and I will also use a 9, and let's check, and I get a 0 as well. So both are valid for that. Okay, now let's continue. We are done with this. We go to 1.2. And this is simultaneous equation. So we will use simultaneous way of looking at things. So we have 2x minus y equals 2 and xy equals 4. So basically what I do whenever I come across a simultaneous equation, and these ones are very basic ones, very straightforward. There are those that requires very serious algebra manipulation, but these ones are just straightforward. So the first thing that I do, I tend to look at these two equations that are provided, and I say to myself, okay, I need to find an equation where the coefficient of x or y is 1. Very important. When you look in here, the coefficient of x is 2. This is going to be problematic if I make x the subject. The coefficient of y there, it's 1, minus 1. Then I can work with this one. And then here, very degraded problem. I don't want to work with this. It's too high. So I will make this equation 1. Why? Because it is easier for me to make y the subject of the formula. Why is it easier for you to do that? It's because the coefficient of y is -1. And then I will number that equation as equation 1. This one is more complicated. I will say that is equation 2. And then I will proceed as to say from equation 1, and then I just write that equation so that whoever is marking the script can be able to see what is happening here. And then from here I will make y the subject of the formula. So I will say minus y, there it is. On this side I have 2. When you take this 2x to the other side, it becomes negative 2x. And then I'm not looking for minus y but y, therefore you divide everything by minus 1 because there's a 1 there. So when you divide by minus 1 here, this becomes minus 2. When you divide by minus 1 there, this becomes a positive. Applying the rule that negative by divide by positive is a negative, and negative by negative is a positive. And then this equation, where I have made y the subject of the formula, I will number that as equation 3. And then I'm going to substitute 3 in equation 2, the one that I have not yet worked on. So in this equation where I see y, I'll be writing 2x minus 2. So I write this equation 3, which is, this equation 2, which is xy equals to 4. So in this equation where I see y, I'll be writing 2x minus 2. And I have my x, there it is, but I see y, because this is a multiplication and I have more than one term, I will make the brackets. Then I substitute my 2x minus 2. And remember, this is equals to 4 because I'm substituting there. And then once that is done, I will just do what? Remove the brackets by multiplication. X times 2x is 2x squared. X minus, x times negative 2, it's negative 2x. Bring this one to the other side, minus 4 equals to 0 because there's nothing left this side. And then from there I can see that 2 can enter in all of them without leaving a remainder. Therefore I will divide throughout by 2. 2 into 2 goes once, you are left with x squared. 2 into 2 goes once, you are left with minus x. 2 into 4 goes 2 times, this is equals to 0. Can you find the factors of 2 that can give you 1? Yes, that's 2 and 1. The bigger number takes the sign of the middle term. When you multiply them, they should give you a negative, therefore this one should be positive. So that minus 2 times 1 is minus 2, and 2 minus 1 is minus 1. Very important. We are back to what we know. So I'll just say x minus 2 equals to 0, x equals 2, x plus 1 equals to 0, x equals minus 1. And I'll name that as my equation 4. Because remember, this is simultaneous. You need to find both x and y. So you have x, you still need to find y. Hence, I'm saying this is equation 4. So I'm going to substitute 4 in 3. So I write down first what 3 is. Y equals 2x minus 2. So from here, I'm going to start first by substituting 2. 2 into 2 minus 2, it's 2. And then secondly, I'm going to substitute minus 1. 2 into minus 1 minus 2 is minus 4. And then I have solved simultaneously for both x and y. You can just go and substitute the values to check whether this is correct. I don't have a memorandum. Let's go to 1.3. 2 times 5 to the exponent of n minus this plus that. And then they say to us, okay, let me just take you back to what the question requires. In 1.3, they say, show that this is even for all positive integer values of n. Show that. All right. So with my little understanding, with my level 2, level 3 knowledge of mathematics, I was able to play around with this. And what I firstly did was to write the original expression. And then once I have had this expression, I just came here, 2 times 5n, because I cannot change this. But I can manipulate this to say 5n times 5 to the exponent of 1, because when I multiply the same bases, I add the exponents. The same I did for that. And then I can see immediately that there's a common factor that exists in here, in there, and also in there. So what I just did there was to just take out a common factor, which is 5 to the exponent of n. I took 5 to the exponent of n here. I'm left with 2. There it is. I took it there. I'm left with minus 5. Please be very careful here. There's a minus there, minus 5. And then I took it there. It's positive. I have my 25. I just insert this on a calculator. I get 22. 5 to the exponent of n into 22. And then I ran a test just to check whether I will get this even. Remember what they said. For positive, they said for all positive integer values of n. Positive integer values of n. Alright, and then what is it that I did? I started first with a positive integer value of n, and I substituted 1 and I get an even number. Let me show you what I did. So I just came in here and I just said 5 to the exponent. Let me take a 0 because 0 is also an integer and it's positive, and I say 22 and I get 22. Is this even? Yes, it is divisible by 2. So I went on and I did with 1. Is this even? Of course. And I went with 2, and this is even. So you can do it with any positive integer value of n. You can even use a 6 there. And is this even? Of course it is even. Therefore I concluded. And then I said n is even for all positive integer values. And then that was that. Right, let us continue with this. And then we went to, let me check. Yeah, we went to 1.3 and then that was fine. And then I went to 1.4. But let me just show you what 1.4 was saying, because it was the last question that we had. Determine the values of x and y if 3 to the exponent of x plus 1 divided by 32 equals the square root of 96 to the exponent of x. With my level 3 in mathematics, I don't think I can do this, but I can try. Try is the best. Try is the best thing ever you can do. So I just copied down the original problem. There it is. And then I noticed something, that I can manipulate this 32. And how can I do that? Oh, sorry. Let me just do this. Escape. And then I just went to look at that 32, and I said 32 equals shift and fact, trying to write that as a product of its prime factors, and I got 2 to the exponent of 5. And then I just left this. What is inside of the bracket, the square root, was left as it is. Remove the square root 1.5. This is exactly what I did. And be that as it may, let's just continue with this. And then once I have done that, I came here. What I did was to cross multiply, as you can see, because I can do this whenever there's an equation with a fraction and a fraction. I can cross multiply. 3 exponent x plus 1 multiplied by 1 is that, and this times this is this. And I've changed nothing basically. And then from there, what I did was just to manipulate this as 3y 3 1. You know, when you multiply you add, nothing is new. And then I went to write this as a product of its prime factors. 96, 2 to exponent 5 times 3 only this number, there it is, and it is raised to exponent of x, and the entire thing is raised to exponent of 1/2. You have to be careful when you do that. And then from there, what I did, I left this 2 to exponent of 5 as it is, and then I multiplied every exponent in here by x. You write your base 2, 5 times x is 5x. You write your base 3, there's a 1 there, 1 times x is x, raised to that. Nothing new in here. And then we continued, and then from here, look what I did. I said when I multiply numbers of the same basis, I just add the exponent. Is that what I did? No. I multiplied everything that is inside of the brackets by 1/2. You need to be very careful there. So I wrote this 2 to the exponent of 5, and then what I did was just to say 5 times x is 5x. Okay, I did that step. Sorry, we are here. And then when I am here, I want to get rid of this 1/2. So what I did, I multiplied every exponent by 1/2. So you have 5x times 1/2, that will give you 5x and half, times you have your x here, you multiply that by 1/2, you will get x divided by 2. And then from there, you can begin to remove the brackets by multiplication. When you multiply numbers of the same basis, you just simply add the exponents. So 5, there it is, plus, when I multiply, I add. And this is not equals to that. Please be careful there. You cannot say 5 plus 5 and half x is equals to this. They are not like terms. 1 plus x is 1 plus x. 5 plus 3 over 2x is 5 plus 3 over 2x. They are not like terms. You cannot get this. Very, very important. And as a result of that, I couldn't find a solution for this. I had to dig way much deeper than what I had to do there. So what I did, I started afresh in this page, because I was defeated in the previous one, and I wrote it exactly the way it is here, as you can see, just as we did previously. And here everything was exactly the same way. I changed nothing. And instead of using cross multiplication here, I decided no, what I'm going to do, I'm going to write this as a numerator. And when I take this on the numerator here, remember the exponent changes the sign. Why did I do that? I did that because I wanted to create the basis of 2 on both left and right, and the basis of 3 on both left and right, so that I can equate. This is something that we did when I was doing first semester in electrical engineering. We were dealing with vectors. I remember well, we were dealing with vectors, and we were calculating the flux density of electrical wires and everything like that. So this is what we were using, binomial theorem. Very important. We were in binomial theorem, and I recalled that because it's been many years now. I am now a professional software engineer, so I remembered that step. What if I try to write it in that way so that I can equate? Let me check if it would work. So I took this to be on the numerator, and then the exponent changes the sign. There it is. Right, and then when I am here, I multiplied everything that was inside of the brackets by x, and this is what we have. Remember, it has to be raised to the exponent of 1/2. And then when I'm there, I multiplied everything, every exponent in here by 1/2, and this is what I got. 5x divided by 2 and x divided by 2. This is what I have. you understand this. Nothing is new. 5x times 1 half, it's 5x over 2. X times 1 half is x over 2. And then now look what I have created. I have formed a base of 3 with an exponent on the left, base of 3 with an exponent on the right. And I cannot equate 3y plus 1 with 3x over 2 because I will be working with the two unknown variables. What I can simply do is to equate these ones because I can find the value of x. And I know that when the bases are the same, you equate the exponents. And that's exactly what I did. Minus 5 is equals to 5x divided by 2. And then when you are here, you just cross multiply. Negative 5 times 2 is negative 10 equals 5x. Divide both sides by 5. Your x is minus 2. And then now I have the value of x. I can find the value of y by substituting the x value there of minus 2. And then I find my y to be minus 2. So when x is minus 2, y is minus 2 also. So this is also simultaneous, but you need to understand very deeply how the algebra works in this. So guys, that was just basically question 1, and I'm just going to pause the tutorial. I will see you in question 2. Thank you for watching. Welcome to the second part of our question paper, and I believe that you guys have understood what is happening, and I hope you have learned something. Unfortunately, I don't have those pen, you see, whatever that I can be able to write on the screen, and then we can just have this interactive learning. So I just rely on a pen and a paper and then this PowerPoint. So you just have to be patient with me. So here we are. We completed question 1 entirely, and I don't know whether everything we have done was correct, but for me it was logic and correct, so I will just not complain on that. Now we need to move on to question 2, and then that will bring us to the end of our lecture for today, this question 2, and then we will proceed tomorrow again just to give you something to work on. Some of these problems and most of these problems, they are repeating themselves from the previous question papers, because I have seen some of these problems in the previous years. So the examiner, whoever is setting this question paper, is trying very much to get as many students as possible to university level. So in question 2, we have the first term of a geometric series. Very important that you understand here. We are dealing with a geometric series, right? The first term of a geometric series is 14, and the sixth term is 448. Calculate the value of the constant ratio, because a geometric series or geometric sequence, if you want to find the ratio, you have to say T2 divided by T1 equals T3 divided by T2. We know this. You have been doing this since early January. This is the first chapter that you deal with. So here I was given that the value of the first term, which is a, that is 14, and I was also given the sixth term, which is 448. So I know that T6 is equals to AR exponent 5, because remember T1 it's A, T2 it's AR, T3 AR squared, therefore T6 it's AR to the exponent of 5, and that is equals to 448. Fortunately, I have the value of A, it's 14. I have substitute 14 there. AR5 equals 448. I will divide both sides by 14. It will give me 414 divided by 448 divided by 14. And then I'm not looking for r to the exponent of 5. I'm looking for just the value of r to the exponent of 1. So you will introduce the fifth root on both sides. So this into this goes once, and then you have the value of r as being equals to 2. So let me show you how I did this. So I just came here and I just said shift and I pressed in here, and that was 5, and I just said 448 divided by 14, and I got the value of 2. So that is the ratio that one has to divide by in order to get the next consecutive terms. Okay, be that as it may, that was 2 marks. In 2.1.2 they say determine the number of consecutive terms. Consecutive. That must be added to the first 6 terms of the series in order to obtain a sum of that. So determine the number of consecutive terms. These terms goes in this order of how can I put this? In this order, one after the other. Let me put it that way: T1, T2, T3, T4, T5, T6. That's consecutive. So determine the number of consecutive terms that must be added to the first 6 terms in order to obtain that sum. So the first thing that I do, I calculate first the sum of the first 6 terms and find out what that value is. So what I did first was to calculate the sum of the first 6 terms. Remember, it's a geometric series, and for series we use a to the exponent rn minus 1 r minus 1, where the value of r is not equals to 1. So I have the first term, which is 14. I have my r, which is 2. Number of terms, I'm calculating the sum of the first 6 terms, and it will give you 882. Okay, that is fine. And then what I did, I took the sum that was provided, 114, and I calculated n again. But notice that when I find n being equals to 13, what is that? That is the sum of the first 13 terms. And the question was saying, find the value of n, the number of terms that must be added to the first 6 terms in order to have that value. So I said to myself, okay, let me look at the second approach. And what I did was to say, now that I have the sum of the first 6, I said total sum that was provided minus S6 is equals to Sn. And then when I subtracted there, I got this value, and then I used that value there. And then I said this, and then I'm looking for n, and I think I found n as being equals to this. So I had to manipulate, where is it? I had to manipulate in here. As you can see, 113792 divided by 14, it gave me this value there. 8128 equals to n minus 1. Remember I have this. When you divide by 14, you will be left with 2n minus 1 and the division of those two, which is 8128. And then I take this one to the other side, it will be 29 equals that. I tried to write this as a product of its prime factors. I cannot find a base of 2. So what I did, let me show you what I'm trying to say. When you come here and you say 81, 29 equals shift fact, trying to find a base of 2, it's impossible. So you can't do that. So what I did was to say, okay, since I cannot do that, what I can do is to introduce the log on both sides. So the log of 8129 equals the log of 2 to exponent n. Bring down n log 2 equals that. Remember, you are looking for n, divide both sides. And I found 12.99, something like this. but I know that n cannot be a decimal. It has to be a whole number. So I rounded off this to 30. Just as I found it in here. Remember, I found n to be 30. And then what I did from there, I said, okay, therefore 13 minus 6 equals 7 more terms. Why did I say 13 minus 7? Remember 13 minus 6. Remember I found the sum of the first 6 terms, and this is the sum of the first 13 terms. So you have to say 13 minus 6 and then you get 7. So 7 more terms must be added to sum of the first 6 terms in order to obtain that value that they want. Okay, and then I went to 2.1.3. And then let's just check what was happening there. If the first term of another series is 448 and the sixth term is now 14, calculate the sum to infinity of the new series. So we are provided with A, which is 448, and T6, which is 14. So what I did was to say AR5 equals 14, but the value of A this time is 448, and you will find when you manipulate there your R, it's 1/2. And then remember, sum to infinity equals A divided by 1 minus R. And you ask me, why did you use this geometric sequence formula? Because only with infinity is calculated using a geometric sequence. That's why I have used this formula in order to find the value of R. And then sum to infinity equals A divided by 1 minus R. You have your A, 448, 1 minus 1/2. You will get 896 as sum to infinity. Okay, that is fine. We can go to 2.2 and let me just check what they were saying there. If we have a sigma notation, which is a sum, if the sigma kp equals 0, 1 over 3p plus 1 over 6 equals 20, 1 over 6, determine the value of k. Now remember, to find k, which is the number of terms, you say this plus this minus 1. So k plus 0 is k minus 1, it's k minus 1, but we will deal with that. I was just reminding you. So here we have it, and this totals to that sum. The first thing I need to find out is what type of a sigma is this. Is this a arithmetic series or geometric series? So I go to the formula that defines this, which is 1/3 p plus 1/6. And then what I did there was to substitute first 0, and then it gave me 1 over 6, 1/2, 2, this, and so on. Now, first of all, I tried to check T2 minus T1, will it be equals to T3 minus T2? And that was correct. And that was correct. I found 1 over 3 equals 1 over 3. So this is an arithmetic series. And then how do I find the sum of an arithmetic series? Sn equals n over 2, 2a plus n minus 1 times d. And then I have this sum, 20 and 1 over 6. It's a mixed fraction. You can also say 20 plus 1/6. It will give you 121 over 6. N over 2 into this. What am I looking for? The value of n. Because I have my a, it's 1 over 6. I'm looking for n, and the difference, it's 1/3. And then after long mental strain there, I find 121 divided by 6 equals n squared. And then what I can do there to get rid of the denominator, I can multiply both sides by 6. And then that will give me 121 equals n squared. I'm looking for n, not n squared. I will square both sides. Remember, n cannot be negative. You'll get plus or minus 12. But you will take a positive value. So n is equals to 12. N, the number of terms. But I'm looking for k. But I know k plus p minus 1 is equals to n. So 12 plus 0 minus 1 is 11. So n equals to 11. If the number of terms is 11, so what will be k? K will be 11 plus 0, which is 11 minus 1, which is 10. It's very tricky, but it is worthy of noting. So this is all, guys, what I wanted to share with you. I hope and believe that you have understood, and I will see you tomorrow.